All right, these are problems number 7, 31, 32, 35, and 40 through 43 from the exam review stamp sheet. Question number 7, no calculator. All right, which of the following statements is false? All right, A, well, let's start with A. It says that f of x is equal to the natural log of x. All right, and it says f of x is equal to the natural log of x has a domain of all positive real numbers. All right, and which is true because the value a cannot be negative. I mean, there you go. If you want to look at the graph of this, all right, a quick sketch. All right, you should know what the natural log of x kind of looks like. All right, and in this case, we at least know that there's an asymptote at x is equal to 0, and the graph is going to go in this fashion. All right, that's one of the things you need to know about logs. All right, it has a vertical asymptote. All right, and so in this case, the domain is x is greater than 0. All right. Also, B. So this is true. A is true. All right. The f of x is equal to the natural log of x increases without bound as x increases without bound. So as x increases, as x goes to the right, y will go up. All right. And so A and B are true. All right. C. All right, we get to C and we start to deal with a little bit of transformation. So it says the graph of g of x is equal to e of negative x. E to the negative x is the graph of f of x is equal to e to the x reflected about the y-axis. So that's our transformation. Now, I don't need to graph it to see, but let's graph it anyway because we want to have some idea. So if we start with f of x is equal to e to the x, all right, we have an increasing, all right, because e is 2.7 something, all right, and so when we do this graph will look like that, all right. I should just know that that's an exponential growth. All right, and if I put a negative, if I make the exponent negative, all right, then this will flip my graph along the y-axis, all right, or reflect it, all right, and so I will have that horizontal symmetry, all right. I'm sorry, vertical symmetry. All right, as we look at that, this graph g of x is equal to e to the negative x. All right, that would be that graph. So question is it reflected about the y-axis? And it is reflected along the y-axis. All right, so that leaves us with D. All right, and since we have the graph here already of g of x is equal to e to the negative x, we can see, well, it says as this graph has a range of all real numbers, and that's obviously not true if there's an asymptote at y is equal to 0 and the graph is above the asymptote, all right, above the x-axis, all right, and so the answer is D, all right. In other words, that's the one that's false, all right. Problem number 31 and 32. All right, it says eliminate the parameter to find the relationship between x and y. All right, so to eliminate the parameter, we have to plug one equation into the other for t. All right, the easiest way to do this, or what I would consider the easiest way, let's write this problem, 31. And we're going to move out a little bit. All right, 31, x is equal to 3t. y is equal to 6t minus 7, all right, is to, now we first have to solve for t for one of the equations. So I'm going to take the first equation, all right, and that's going to give us, if we solve for t, we're just going to divide both sides by 3, all right, that will give us t is equal to x over 3. Now, from there, we are plugging that equation into the second equation, and that will give us y is equal to 6 times x over 3 minus 7. All right, and we simplify that. All right, well, in that case, we end up with 2x minus 7, and we should know that that is a line. All right, 32. All right, 32 is x is equal to 2t plus 4, y is equal to 4t plus 5. All right, and we need to solve for t for one of the equations. So I like choosing the x equation to solve for t. All right, because I'll end up having y is equal to something, which leads us into a better equation, or being able to recognize the equation. All right, so x is equal to 2t plus 4. Subtract 4 from both sides. That gives us x minus 4 is equal to 2t. Divide both sides by 2. We get t is equal to x minus 4 over 2. All right, and now we're going to take that and plug it into the second equation. That will give us y is equal to 4 times x minus 4 over 2 plus 5. All right, and in that case, I go y is equal to, well, 4 over 2 is 2 times x minus 4 plus 5. All right, and that's going to give us 2x minus 8 plus 5, and y is equal to 2x minus 3 as a final answer. All right, that's 31 and 32 down. All right, number 35. All right, it says write vector and parametric equations of the line that passes through the points 1, 4, and 3, 9. All right, so your points are 1, 4, and 3, 9. All right, and it's fairly simple when we have this situation. So let's say we have it over here. All right, for all these situations, if we have x1, y1, and x2, y2, all right, writing it in form, vector form, we say vector x, y, in this case, is going to be x1, y1, and then I'm running out of space here, plus x2 minus x1, comma, y2 minus y1. All right, so let's go ahead and do that. Takes a second to do. All right, so our vector form is x, comma, y is going to be 1, vector 1, 4. So that gives us a point on the vector. All right, and plus 3 minus 1 and 9 minus 4. All right, and so that will give us vector 1, 4. Oh, I apologize. There should be a t here. Sorry about that. There should be a t there. So plus t, 2, 5. Now, to write that in parametric form, all right, we write this in parametric form. It becomes, we just take all the x's. X is equal to x1 plus t times x2 minus x1, and y is equal to y1 plus t times y2 minus y1. All right, so to do that in parametric form, this is x is equal to our 1 plus 2t, and y is equal to 4 plus 5t. And we're done with number 35. Numbers 40 through 43. All right, for items 40 through 43, use the vectors given. All right, we want to do the dot product for number 40. All right, and so our dot product, all right, for number 40, so we have A is equal to 2, negative 3. We have B, vector B is 6, 5. Vector C, we can erase that. Vector C is R, negative 9. All right. Now, dot product, we're just multiplying our x coordinate components, multiplying our y components and adding it together. All right, so for number 40, we have 2 times 6 plus negative 3 times 5. All right, that's going to give us 12 minus 15, which is for number 41. It says find the measure of the angle between vector A and vector B to the nearest 10th degree. All right, and so in that case, it's kind of looking for the equation for you. All right, can't find the equation. All right, but theta is equal to the inverse cosine. In this case, since we're using A's and B's, we want to do the dot product of AB all over the magnitude of A times the magnitude of B. All right, so we got 3 different things to do. One of them we've already done, and so from here we would like to do the magnitude of A and the magnitude of B. So the magnitude of A, all right, is going to be the square root of 2 squared plus negative 3 squared. All right, that's going to give us the square root of 4 plus 9, which is the square root of 13. All right, and the magnitude of B is It's going to be the square root of 6 squared plus 5 squared. And that is the square root of 36 plus 25, which is 61. Square root of 61. All right, and so now we have everything that we need in order to find the angle between. We go theta is equal to inverse cosine of the dot product of AB, which is -3 over the square root of 13 times the square root of 61. All right, in our calculator, we can multiply this denominator. That's going to give us inverse cosine of -3 over the square root of, I think it's 793. All right, checking your calculator. All right, and then we can do this in the calculator at this point. Making sure your parentheses are correct, but we should end up with 96.1 degrees. All right, number 42, keep it moving. Number 42 says, find the value of R such that A and C are parallel. All right, so I'm going to erase this so we can use what we have at the top. Bring that down. All right, so number 40, are we still at 40s? Yep, 42. All right, we want A and C to be parallel. All right, so looking at A, which is 2, -3. All right, and C, which in this case we want to find R to make those parallel. Now, quick way of looking at this is to say, well, what would I multiply -3 by to get -9? All right, that would be 3. And then I can go 2 times 3 is 6. All right, now will give me R. All right, that's one way to look at it. Other way is to, so we would go, well, let's just do it that way. All right, if I divide these, all right, I end up with 3. All right, and then I also want to go corresponding R over 2 also would have to give me 3. All right, because these have to be proper ratios. All right, so in order to do that, I would just solve R. All right, multiply both sides by 2. R is equal to 6. All right, and it would have to be 6 in order for those to be parallel. Now, in order for them to be perpendicular, which I think is number 43, then the dot product must be equal to 0. All right, in order for those to be parallel. All right, so let's look at that. All right, if I do the dot product of A and C, I go, well, let's rewrite A for a second. A is equal to 2, -3, and C is equal to R, -9. So what we're saying is that 2 times R plus -3 times -9 has to be equal to 0 in order for them to be perpendicular. All right, so in that case, let's just solve that. 2R plus 27. Or am I writing the correct equation? Is it A? BC. Sorry. Whoa. Okay, I caught myself. I don't want to redo this video, so we're gonna go B, vector B, and that's 6, 5. Apologize. All right, so I'm glad I caught it. All right, we're going to go 6 times r plus 5 times negative 9 must be equal to 0. All right, and that's 6r minus 45 equals 0. Add 45. That's 6r is equal to 45, and r is equal to 7.5. All right, and that's another stamp gone.